Hello, my precious friends. I really hope that you are doing great. Welcome to our today's class. It's our second lesson on the second topic of Form 3 work, which is called Refraction of Light. As usual, let me commence by giving you the quote of the day, which states that don't dwell so much on your weaknesses because everyone else is already doing that for you. Instead, focus on your strength because that is the only way you can improve. We shall discuss that quote at the end of our class today. So today we are looking at refractive index, and remember from our previous class we did look at the Snell's law, whereby we did say that it was discovered by a Dutch mathematician by the name Wilbrod Snellius in the year 1621. From the Snell's law, we did say that it says that the ratio of the sine of the angle of incidence to the sine of the angle of refraction must be a constant. Suppose we have a ray of light moving from medium 1 to medium 2. It means that for such a given ray, the angle of incidence will always be the angle made between this particular normal and the incident ray. Therefore, if we want to find the refractive index, we shall be talking of sine I divided by sine R, which is equals to the refractive index. And because our ray of light is moving from medium 1 to medium 2, then this is a refractive index from medium 1 to medium 2. So we let this to be our first equation. Now, suppose we have the same ray of light moving now from medium 2 towards medium 1. So it means that in this case, our R will become our angle of incidence, while I will become our angle of refraction. Because remember, the angle of incidence is always the angle made by the incident ray, that is the ray that is emerging from our source of light. Then it means the interface. So the angle of incidence is always the angle between the normal and the incident ray. Therefore, in this particular case, R is our angle of incidence. Then the angle of refraction is always the angle between the normal and the refracted ray. And in this particular case, I is our angle of refraction. Therefore, when we talk of the Snell's law, that sine I divided by sine R should be equal to a constant. Remember that I, the angle of incidence in this case, is R. Therefore, sine of the angle of incidence, which is R, divided by the sine of the angle of refraction. The angle of refraction in this particular case is I. So divided by the angle of refraction in this case, which is I, should be equal to the refractive index of this particular ray moving from medium 2 relative to medium 1. So the angle of incidence in medium 2, that is angle R, the sine of angle of incidence in medium 2, which is R, divided by the angle of refraction in medium 2, which is I. Therefore, the refractive index from medium 2 to medium 1, we represent it by 2 to 1. That is the angle, the refractive index of a ray moving from medium 2 towards medium 1. Therefore, we note this as our equation 2. So the reason why we are talking of sine R divided by sine I in this particular case is because our R, that is the angle of R in this particular case. Remember now the ray is moving from downward towards the upper direction. Therefore, this becomes our angle of incidence because the ray is coming from this particular point. But for this case, this was our angle of incidence because the ray was moving from the upper point towards the normal, and then from the normal it emerges downward. So for this case, this was the angle of incidence and this was the angle of refraction. But if we have the same ray moving now from downward direction as shown in this particular diagram here, from the downward direction towards the upper direction, then it means R becomes our angle of incidence, and that's why we are talking of sine R divided by I becomes our angle of refraction. That's why you are talking of sine R divided by sine I being equal to the refractive index of a ray moving from medium 2 towards medium 1. So 2 to 1. So we let this to be our equation 2. Now, if we combine equations 1 and 2, we get that from equation 2, we have that sine R over sine I should be equal to the refractive index of a ray moving from medium 2 towards medium 1. Now, if sine I over sine R over sine I is just the same as saying the reciprocal of sine I divided by sine r. That is, sine r over sine I is equals to the reciprocal of sine I over sine r. Because if you find the reciprocal, it means we are dividing. So 1 divided by sine I over sine r is just the same as saying 1 times the reciprocal of that particular value. Therefore, 1 times the reciprocal of sine I over sine r, so its reciprocal will be sine r over sine I. Therefore, 1 times sine r over sine I, it gives us sine r divided by sine I, which is the same as our original equation. So sine r over sine I is just the same as the reciprocal of sine I over sine r. Having deduced that, we can simply conclude that sine r over sine I is equals to 1 over sine I over sine r, because one is the reciprocal of the other. Now, from our equation 2, this particular equation here, sine I over sine r, that is sine r over sine I, is the same as saying n2 to 1. That is the refractive index for a ray moving from medium 2 towards medium 1. Hence, sine r over sine I is the same as n2 to 1, which is equals to the reciprocal of sine I over sine r, which is the same as saying from equation 1, sine I over sine r was equals to a refractive index from medium 1 to medium 2. Therefore, we'll be talking of 1 divided by the refractive index from medium 1 to medium 2. That is 1 over n1 to 2. Therefore, this particular relationship will be very important when you are given maybe the refractive index of a ray moving from one medium to another. Then maybe you are asked to find a refractive index for a ray moving in the reversed direction. The same equation can also be expressed as, we can multiply on both sides by n sine that is n1 to 2, that is to eliminate the fraction. If I multiply both sides by n1 to 2, I'll have n1 to 2 times n2 to 1 being equal to 1 over n1 to 2 times n1 to 2. Of course, refractive index from medium 1 to 2 and from medium 1 to 2, they'll cancel out, so that we remain with n medium 1 to 2 times n medium 2 to 1 being equal to 1. Then if I divide both sides by n from medium 2 to medium 1, I'll remain with n medium 1 to medium 2 being equal to the reciprocal of n medium 2 to medium 1. So these particular equations can help us to compute some calculations. So let's look at an example. So example 1 reads that a ray of light striking a transparent medium is refracted as shown below. We are required to calculate the refractive indices n1 to 2 and n2 to 1. Remember, indices is just the plural of an index. So when we are talking of one refractive index, we just talk of an index. But when they are in plural, we talk of indices. So refractive index for part A from medium 1 to medium 2, it will be equal to medium 1 to medium 2. We are talking of sine I divided by sine r. That is courtesy of the Snell's law by Wilbrod Snellius. So from our first diagram, a ray of light moving from medium 1 to medium 2, the angle of incidence is always the angle between the incident ray and the normal, and in this case it is 75 degrees. So we talk of 75 degrees divided by the angle of refraction. In this particular case, the angle between the normal and the refracted ray, which is 47 degrees. So sine 75 degrees, you get 78 3, that is sine 75 degrees divided by sine 47 degrees, you'll get 78 358 divided by 59 329, which is approximately 1.3207. Then another point to note is that refractive index is a ratio, therefore it does not have any units. Then refractive index of a ray moving from medium 2 to medium 1, we shall be talking of now our ray is moving from the downward direction from medium 2, then moving upwards. It is changing direction. It's just moving like this particular ray here. So from medium 2 to medium 1 means that the ray of light is starting. That is, the angle of incidence will be in medium 2. Then the ray is being, the refracted ray will always be in medium 1. Therefore, refractive index from medium 2 to medium 1 will be sine r over sine I. The reason being, R in this case will be our angle of incidence, because we are talking of a ray of light moving from medium 2 towards medium 1. That is like shown in this particular case here. So you can see that I is the angle of incidence, while R is the angle of incidence, while I becomes the angle of refraction. Therefore, sine R over sine I will give us the angle of incidence, which is R in this case, is 47 degrees. So sine 47 divided by angle of refraction in this particular case will be this particular angle of 75 degrees. That is for a ray moving from medium 2 towards medium 1. So sine 47 divided by sine 75, you'll get 59,329 divided by 78,358, which is approximately 0.7572. Alternatively, you can also just compute refractive index from medium 2 to medium 1 using the refractive index from medium 1 to medium 2, courtesy of the equation that we have just derived up here. Now, we have said that refractive index from medium 2 to medium 1 is the same as the reciprocal of the refractive index from medium 1 to medium 2. So because we had already found the refractive index of medium 1 to medium 2, we just say it will be equal to 1 divided by, that is the refractive index from medium 2 to medium 1 will be equal to 1 divided by refractive index of medium 1 to medium 2, which was 78,358 divided by 59,329. So 1 divided by 78,358 divided by 59,329, it will be equal to, remember when you divide, you multiply by the reciprocal. So 1 times the reciprocal of this, we shall just get 59,329 divided by 78,358, which is approximately equal to 0.7572 as our refractive index, which is just the same as this particular value there. Example 2 reads that calculate the angle of refraction for a ray of light from air striking an air glass interface, making an angle of 60 degrees with the interface. Now remember, an interface, this is just a point whereby the angle of incidence, the angle of refraction, and the normal do meet. That is what we mean by the point of incidence. Then when we talk of air glass interface, we mean that the ray of light is moving from air towards the glass. Therefore, the angle of incidence will always be in the air, that is the first medium. Then the angle of refraction will always be in the glass, that is the second medium. I've just sketched that here. So this is what the information means, because we are told that we are required to calculate the refraction, the angle of refraction for a ray of light traveling, that is from air striking an air glass interface, making an angle of 60 degrees with the interface. So the interface is actually this particular horizontal line here. Therefore, we are told that the ray of light is making an angle of 60 degrees with the interface. So if this is my ray of light, then this is the interface, then the angle that it is making with the interface, 60 degrees, is this particular angle here. Now, we are also given that the refractive index from air to glass is 1.5. It is 1.5. Then we are required to find the R, the angle of refraction. So it is just this particular diagram here. The ray of light is coming from air, then it is moving towards the glass as our second medium. Then of course this is our point of incidence. Now from our diagram here, remember the angle of incidence is always the angle between the incident ray and the normal. So this particular angle here is our angle of incidence. Then the angle of refraction is always the angle between the normal, which is the vertical here, and the angle of refraction. Therefore, the angle of incidence I will be given by, remember the normal usually makes an angle of 90 degrees with our interface. Therefore, the angle from the normal to the interface is always perpendicular, or is always 90 degrees. Therefore, if we want the angle of incidence here, we shall take 60 degrees minus, we shall take 90 degrees minus 60 degrees for us to get this particular angle of incidence. So angle of incidence is equals to 90 minus 60 degrees, which is equals to 30 degrees. Then we are given that refractive index from air to glass is equals to 1.5. Therefore, we know that refractive index from air to glass is the same as sine I divided by sine R, courtesy of the Snell's law. Therefore, if I substitute the values that I have, I'll be talking of refractive index from air to glass. I'm given as 1.5. Therefore, 1.5 is equals to sine I, that is the angle of incidence, is 90 minus 60 degrees, which gave me 30 degrees divided by sine R. Therefore, if I cross multiply or I multiply both side by sine R, I'll have 1.5 times sine R being equal to, remember sine R and sine R on this side will cancel out, so that I just remain with sine 30 degrees. Therefore, if I make sine R subject of the formula, I'll divide both sides by 1.5, so that I have sine R being equal to sine 30 degrees divided by 1.5. Then we know that sine 30 degrees is 0.5. 0.5 divided by 1.5, you will get 1 over 3. Then if I want the value of R alone, I'll just take, I'll take the sine inverse on both sides. Therefore, R will be equal to the sine inverse of a third, which is approximately 19.5 degrees. Remember, when you're giving angles, it is advisable just to leave it correct to 1 decimal point, because we know that this is the maximum degree that a normal protractor can measure, and that is why we usually express angles correct to just 1 degrees. Next, we look at another example which reads that use the information in the figures below to calculate NA to water, then the angle theta. So NA to water, NAW means the angle of incidence from air to water. So from our first diagram, we are given air to water. We are given a ray of light starting from air, then emerging from the water. So that means the angle of incidence will always be in the air, and the angle of refraction will always be in the water. Then we are given the angle between our incident ray and the interface as 48 degrees. But remember, the angle of incidence is always the angle between the normal and the incident ray. Therefore, if we want to find a refractive index from air to water, we'll talk of sine I divided by sine R, courtesy of the Snell's law, which is equals to sine I is the angle between the incident ray and the normal. So this particular angle here, this angle here. Of course, we say that the normal always makes an angle of 90 degrees with the interface. Therefore, if this angle is 48 degrees and the angle between the normal and the interface is 90 degrees, therefore the angle of incidence, which is this angle up here, it will be 90 degrees minus 48 degrees. Therefore, sine I is 90 minus 48 degrees. Then sine R. Sine R, remember R is always the angle between the normal and the refracted ray, which is this angle down here. Then also the normal will always make an angle of 90 degrees with the interface. Therefore, the angle of refraction will be 90 degrees minus 60 degrees. So 90 minus 60 degrees. So you compute 90 minus 48, you get 42 degrees. 90 minus 60, you'll get 30 degrees. Therefore, sine 42 degrees divided by sine 30 degrees, you'll obtain 874 divided by 38,015, which is approximately 1.34. Then part B, we are required to find the angle theta. Remember, for us to find the angle theta, we just refer to this particular diagram here. And what is happening here is that, first of all, the ray is moving from air to water medium. But for the second case, now the ray is moving from water to air medium. So there is change in direction of motion of our ray within those particular two media. Therefore, the refractive index from water to air, that is for this particular ray here, because the ray is moving from water towards air, refractive index of water to air, it will be equal to sine I over sine R. Then the angle of incidence will be this particular angle here, which we are given as 20 degrees. Then the angle of refraction will be the angle between the normal and the refracted ray, which is theta. Therefore, sine I, it will be sine 20 degrees, which is the 20 degrees here, divided by sine theta. Then we know that we already have refractive index from air to water. We can use this particular relationship to find the refractive index from water to air, because we know that refractive index from air to water is the same as the reciprocal of the refractive index from water to air, from the formula that we derived in our previous page. Therefore, we already have the refractive index from air to water, we have already found it as 50874 divided by 38015. Remember, I'm using this particular exact value so that I avoid premature approximation. I have not used the value of 1.34 because this is an approximated value, because yeah, it is an approximated value, it is not an exact value. So that's why I'm using this particular initial value so that I avoid errors due to premature approximation. Therefore, N air to water is 5874 divided by 38015, which should be equal to the reciprocal of N refractive index of water to air. So the reciprocal, I'll be talking of 1 divided by refractive index of N, that is water to air. So water to air, I've already found it as sine 20 divided by sine theta. So 1 divided by sine 20 divided by sine theta, which is the same as saying 50874 divided by 38015, which is equals to the reciprocal of this. Remember, when you divide, you multiply by the reciprocal. Then the reciprocal of sine 20 divided by sine theta is just sine theta divided by sine 20. If I do multiply on both sides by sine 20, I'll have sine 20 times sine 20 will cancel out, so that I just remain with sine 20 being equal to 500874 divided by 38015 times the sine of 20. Therefore, sine theta is equals to 50874 divided by 38015 times the sine of 20. Then for me to find theta, I'll find the sine inverse of this particular value here. Therefore, sine inverse of 500874 divided by 38015 times sine 20. You compute this using a calculator. The sine inverse of this, you will get 27.2 degrees. Again, I'm only taking correct 1 decimal point because the largest value that our protractor can give us is an approximation of up to a degree, an angle of up to 1 decimal point. Therefore, I just pick 27.2 degrees. Then of course, I have an exercise here that I recommend you should try at your own free time to gauge whether you have understood the concept that we have just learned. Of course, if you have any challenges in handling all of the questions, feel free to drop a comment specifying the nature of your question, and I'm always there to help where necessary. We've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that don't dwell so much on your weaknesses because everyone else is already doing that for you. Instead, focus on your strength because that is the only way you can improve. So the quote is encouraging us to find a way of always ensuring that our maximum time, our maximum energy, and our maximum effort is spent in our areas of strength. Again, the quote is warning us against spending our valuable time focusing on our weaknesses, because remember that whatever we choose to focus on will always expand. Therefore, if you focus on your strength will always expand. If you focus on your weaknesses will always expand. So the choice is yours. And lastly, remember that you only feel lazy because you don't love the process of doing what you are doing. Therefore, I'll urge you to keep experimenting until you get to know what you really love doing. Because when you get to know what you really love doing, then you'll never feel lazy because you'll always be motivated to do it. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get a notification. In case you know anyone or any student that you honestly think could benefit from this content, kindly do me an act of kindness and refer them to this channel. This is Kind Tuition Academy. Until next time, thank you very much.